Hello everyone. In this video, we'll be seeing how to create histogram plots using Seaborn package. So we'll be seeing the practical implementation of it with the help of an iris dataset. So first, let us load the iris dataset. So first, we'll start with importing the required libraries, Matplotlib, Seaborn, Pandas, and NumPy. Now, under Seaborn, this iris dataset comes under an inbuilt dataset. So, SNS.load dataset method has to be used. In this, the iris dataset has to be called. And we are going to store it under df. So, when we print df, what happens? For each and every class, we'll be having 4 different features like sepal length, sepal width, petal length, and petal width. So, based on these values, the flowers would be categorized. That is what the last column, species, we have Setosa, versicolor, and virginica. There are over 150 flowers in our dataset where there are 50 flowers individually for 3 different species. That is versicolor, virginica, and setosa. Okay, for each and every species, there are over 50 flowers. So now let us see how to create an histplot of it. So histogram basically represents the data in form of some groups. So it is basically used for a continuous data. So if we compare in our data set, we have sepal length, sepal width, petal length, and petal width. All the data under it will be continuous. So for a continuous data, we can make use of histograms such that, for example, in sepal length, we are having the range of sepal length starting from 5 centimeter to 11 centimeter. Okay, the values will be 5.1, 5.3, 7.1, 7.2, 7.5. Let us assume some random data. Okay, so now what happened is that if you are going to create an plot with respect to the sepal length for 150 flowers, okay, it will be taking 150 flowers sepal length, okay, and then it will compare the starting range and end range of sepal length. Let us suppose the starting range is 5 and ending range is 11, right? So between 5 and 11 centimeters, it will be creating different variations. Okay, so we are having 2 different flowers between the range 5.1 till 5.3. Okay, so now let us find between 5 and 5.5, we have 2 different flowers. So the count values of flowers would be provided. So in case of y-axis, we'll be having the frequency. Frequency is nothing but count values. Then between 5.5 and 6, we don't have any data. Between 6 and 6.5, then 6.5 till 7, 7 till 7.5. So 7 till 7.5, if you compare, we have 3 different flowers. So the corresponding count values will be taken. This is how, okay, what happens, it will be taking the starting and ending range, okay, and it will be creating different blocks under it. Okay, these are individual block is called as bins. Okay, let us provide bins equal to 10 means between 5 and 10, okay, between 5 and 10, 10 bins will be created. Okay, 5 and 11, 10 bins will be created. Okay, so depending upon the range, it will be categorized. So here, we have to start with the SNS.hisplot. First argument should be for what column you are going to create this hisplot. So x is equal to sepal width. So for sepal width, you are going to create a hisplot that comes under data equal to df. The data frame where the sepal length basically lies has to be provided. Then we have to provide bins. So bins equal to 10. So 10 different variations, ranges it has to be created, blocks has to be created between the range. Then KDE. KDE stands for kernel density estimator. So when you activate KDE equal to true, the distribution graph, okay, whether it's a normal distribution or skew distribution, the distribution of graph will be activated. So that is why we have to activate KDE equal to true. Then we will show, make use of plot.show such that for sepal length, what happens? It will be having the starting range like 2 and the ending range is 4.5. So between 2 and 4.5, it's going to consider different flowers. So let us consider between 2 and 2.25, what happens? There are over 4 flowers. Then between 2.25 till 2.5, there are over 7 flowers. So likewise, the count value should be provided. Okay, if you check the bin size, there will be almost 10. Okay, so the ranges will be confined such that you will be able to analyze with this graph between 2.97 till 3.48 over maximum number of flowers basically lies. So such kind of inference can be taken from our his plot. And then since we are activated KD equal to true, with this the distribution of graph can be analyzed. So it's kind of almost normal distributed. Okay. Similarly, for each and every categories, you can analyze histogram. Then there is one variation in case of his plot. So we are going to understand. Okay, let us make use of sepal width. Okay, sepal width. So SNS.hisplot, we are going to provide first argument as sepal width, data equal to df, hue. Hue is nothing but since we are having 3 different species, for each and every species, okay, the plots will be provided and the color variations will be provided with respect to hue. Okay, so let's analyze this graph. You see, so for Setosa, versicolor and virginica, so 3 different plots, okay, will be provided, okay, such that the values would be confined and 3 distributions would be created. Okay, such that with respect to the color variation, we can understand, okay, what kind of variation does each and every species will undergo in case of with respect to your sepal width. That's the end of creating histogram plots using Seaborn. Thank you.